Well, hello, my name's Dan and welcome to my shed. Today I want to talk about a project that I've just finished, and this project is something that I've needed for a while, and it is a low-angled aluminium bronze plane. So what I want to do today is give you a little bit of an overview of how I made it, the steps that I took, and the reason why. People said to me, why did you make a plane? Talk to us about why you made a plane. First of all, the reason why I made a plane is there's many things I can't do, but there's some things I can do, and that's working with my hands. And I get a great deal of pleasure out of making things with my hands. In Genesis, in the Bible, it says, on the seventh day, God sat back and looked at what he made, and he was well pleased. And I think there's something for all of us when we make something. Whether it be complicated, whether it be simple, we sit back and we look at it and we see the beauty of it and get a lot of enjoyment. So that's the first reason. The second one is that I haven't seen an aluminium bronze plane at all anywhere. I see brass ones, but not aluminium bronze. And the other reason is that I need one. So why buy something when you can make it? And another reason is because I wanted to be able to use some skills across a lot of different trades. And so I'm looking at designing trade, a pattern making trade, a foundry trade, and a machining trade. And so there's different trades that I wanted to practice and work in. And so here we go. I'll just give you a little bit of an overview of the plane and why I made this particular plane and why I made it out of this particular material. So when we're talking about wood planes, we're looking at a lot of different types of planes, and different planes have different purposes. So when we come down here, we look at these real little, what we call thumb planes, and they got a particular shape to the bottom of them. You'll see that they're curved, and these are violin making planes. Here's a toothed plane, and that's for cutting out where grains go in a lot of different directions. And so instead of peeling the grain out, these take little bits of the wood out without peeling it out. Then you go up in sizes till you get to your bigger one. As you can see, when we go from there, we go to the plane here that fits in between those. And I'm going to make another one that's a little bit smaller than there, but at different purposes of the planes. Here's a Stanley number 4 plane, and this is a roughing plane. And so it means that the blade is a convex, and so it's for roughing out. But here's one, a number 4, and this is a finishing plane. Here we have a number 5 plane, Stanley, and this is for a lot longer jobs where you need to straighten a long job. And here's a number 6, and this one here is for longer jobs again. And this one here I'll probably do up and sell because they're pretty hard to get, and so I'll machine that up and turn it in. And so we get different types of planes, and so this is a low angled plane. And so these planes here, the blades are at 45-degree angle. This one here I've made so that the angle of the plane of the blade is 20 degrees, and then the bevel on the actual blade is at 17 degrees, which makes it a final cutting angle of 37 degrees, which makes it quite good for going across grain. So let's have a look and talk about the procedure that I went through and how I did it. So the first thing I had to look at was the design. What design did I want? And so to draw out a design with the angle and get some sort of an idea of the size and how you want it to do, and just nut the idea around your brain. As you'll see from the plan I've made, it's a little bit different to this one again, because I thought about things as I went, so I changed things. From there we go to a different trade, and we go into the pattern making trade. And this is where now we go from the actual plan, and we make one out now in timber, and the way we want. Now that becomes our pattern, and we'll pack sand around that, and then we'll pour take the pattern out, and then we'll pour the metal into the actual cavity. Here's the pattern for the top. It's a double piece pattern because one part's got to go into the bottom of the pattern, one in the bottom of the sand, and one goes into the top. And so that's the pattern that we make. So from there, we've got to make a mold, and so these are the molding boxes that we use. And so these molding boxes, we have a bottom of it that we call the drag, and then we have a top that we call the cope. And you'll see that they are doweled, and so they fit in there like that, so everything lines up. And when we're doing it, we put that in there, and we pack sand around it, and then and that leaves a cavity in there for the actual metal to flow into. So the sand, we make the sand up. And this is what we call green sand, and this is a fine, very fine sand. And then we put bentonite clay in it, and moisture and a bit of corn flour, and that then we can pack around that, and it leaves that cavity, and it works very, very well. And so that's the sand that we use. So we make that up as well, and so that goes into these boxes, and then we may have a cavity that we can pour the metal into. So let's talk about the metal that we're using. So how do we make aluminium bronze? Aluminium bronze is a brilliant material. It's made up of 11% aluminium and 89% copper. The aluminium I use is from mag wheels because it's a higher quality, and then copper. And so you mix it all together, boil it all up, and I'll show you that in a moment. But the reason why we use it, aluminium bronze, is special qualities that it's got. It's very high wear resistant, work hardens, very high anti-friction qualities to it, very high corrosion resistance. The naval people use it to make the ship's propellers out of it. A lot of ships' fittings are made out of it. And also the aviation industry uses it as well because of its high wear resistance, and it's tough, it's hard, it work hardens. It's a very, very good material. So what do we do? And so now we've got to melt and make the metal up. And so what we do is that I had to make a foundry to be able to do that. And so we can see all the different trades coming together here. So this is a foundry that I've made, and a bit of corrugated iron and some high temperature wool put in around that, and then some refractory cement goes in around that. And there goes the crucible. You can see there's still some material left over from the last pour that I did. And also a burner, and this is an LPG burner that I've made up, and it gets that furnace up, quite high, actually about 1200 degrees C, a bit higher actually, depending on how much gas I put and push into it, and how much air I push into it. So well enough to be able to melt the metal and to pour it. So once we poured it in, I've got another video on that I'll put up at a later stage. But once we've poured it, this is what we get, and this is one that's come straight out of the pour. And here we see the pouring base, we pour into, goes in up around here. This is what we call the sprue, and this sprue is tapered. And the idea of the taper is that we have a positive pressure coming down, and it stops cavitation, which stops it absorbing oxygen, which causes what we call porosity in your actual melt. And so it pours into there, and then it goes, as you can see, it goes into little runners into what we want to cast. So you can see this one here, you can see the beautiful gold. Doesn't it look beautiful? The actual aluminium bronze, it looks absolutely beautiful. And you can see these top bits here, and these are what we call risers. And the idea of the risers is that the metal fills the mold up, and then it'll come up here, and as you can see there, and you can see here as well, is that they're dimpled, and that's the shrinkage. And the idea of putting the risers in is that this will shrink, and your actual job won't shrink. You don't want it to shrink. It'll probably shrink a little bit, but not a great deal. and so all the shrinkage goes out of there. So what do we do from there? Of course, we then cut it all off, all the bits and pieces off, do a rough grind, and then we do a rough machining of it, and set it up in this milling machine that I've got here, and then we mill it, and we mill all the faces and the angles and get them all exactly right from there. You'll see that we have different materials here, and I'll talk to you a little bit about that later. And so that's really the machining part of it. So we machine the angle. So what I might do now is I might pull it down, and just so we can have a better look at it, hey? And so that's once we've machined it, we've machined the top, and this here slides backwards and forwards. That's adjusted there, and you'll see here this is silica aluminium bronze, sorry, and I've put a little bit of stainless steel in there. That these here is a 316 stainless, also that they don't rust or corrode. So those angles have been done. The bottoms have been cut out for the blade to fit through. The top it's made out of aluminium bronze as well. This part here is made out of brass. And I've made that out of brass for a simple reason, is I want to be able to knurl it. And the aluminium bronze is just, you can see where I've tried to knurl that, it's just a bit too hard, because when you're knurling it, you're actually pushing the metal out, and you don't cut it in, you actually push it out. And the aluminium bronze is just a little bit too hard, and as you can see, it doesn't go well. So I had to get some old taps and plumbing fittings, and I've melted them down and re-poured it and machined those up there. And this bottom bit there, that's made out of 316 stainless. The blade, I've made the blade out of 15 and 20 steel. Now there's a few different steels you can use. 01 is a very popular steel. 1084 sorry, is another high carbon steel that you can use, but I made this one here out of 15 and 20, and the reason being is that the 15 and 20, the end means it's got nickel in it, which causes it not to corrode and rust as easily as other blades. And so it's a high carbon as well, high carbon steel. And so when we're making that, we machine it all up, and at that point it's still quite soft. And so what we do is we put it in the furnace, and we heat it up to critical temperature, which is about 815 degrees C, and quench it into oil. I quench this in canola oil, which is a good quenching agent for this type of steel. Different steels have different types of quenching oils. And at that point, once we quench it, it becomes very hard like glass, and it's brittle. And if we were to leave it like that and sharpen it up, what would happen, it would be a very hard, sharp edge, but it'd be too brittle. It'd be like glass, and it would chip very easy. If you dropped it, the chance that you could break it, it becomes that brittle. And so what we do is we put it through another heat treatment called tempering, and we put it in an oven at 200 degrees centigrade, leave it there for 2 hours, and just let it soak in the heat, and let all the molecules and everything settle out, and things like that in the steel. And so the crystal structure of the steel then changes back a little bit, and so it becomes tough, not as hard, not as it was, but it becomes hard, which means that it won't chip like it would if it wasn't hardened. So that's pretty well the making. So why don't we put it together and see how it all works, eh? So a little bit bigger bite off it. So as you can see, it cuts really nice clean chips, and so I'm very happy with it. What are some of the learning things I've learned from it? Is probably a little bit heavy, and compared to the commercially made ones, and this is a Stanley made low angle, very similar design. This one here is a little bit smaller that I've made, but this one here is about 100 grams heavier than this one. And so the learning that I've got out of this, I've had a few requests to make them a plain, and so the ones that I'll make from here on, I'll probably make the top a little bit different so it's lighter, hollow it out a little bit, and so that it's just 100 grams heavier than the commercial made ones. But outside of that, what a beautiful little plane. It especially one-handed, it's really great. It sounds beautiful. You normally tell a good plane the way it sounds as it goes across the, and lovely chips it brings off. So yeah, so that's the aluminium bronze plane. Thanks for watching.